Hello, this is Coco. In this video, I'm going to show you how to use a 4 different classification model in RapidMiner. So the 4 classification model includes the KNN model, decision tree, random forest, and SVM, which refers to support vector machines. Here in the video, we can show that you can see I'm showing my RapidMiner panel. And I'm using the data set called the insurance right over here. And that's a data set we've been obviously using. And then all those green, 4 green operators indicate 4 different classification model. You can see the name right over here. And we have additional step to set the rows for a particular variable, and we also select a subset of attributes before we move our data into the model. So on the top, I put the 3 notes in showing you these 3 steps for the model. For all the classification model, what we need to do is that firstly, we would like to load our data. So it's the same as all other process. And the second step we would like to do is to set the rows, basically select the output variable. Because this is our classification model, we would like to pick a categorical variable as the output. In RapidMiner, you need to tell RapidMiner which variable will be the output and which is going to be the input. So RapidMiner use the thing called the row to manage the input and output. And the RapidMiner has an operator called setRow. You can simply search in the operators list, just call setRow right over here. So this operator is what I put here. And you can use the setRow operator to change the row for a particular variable. If you click the setRow operator, you will see on the panel for the parameters, and you can choose which attribute you want to change. Here in my example, I'm using the variable smoker, which is a binary categorical variable and only includes 2 categories, yes and no. And we're going to use it as the output variable. And then for the target row, which means what do you want to change? And we can tell RapidMiner that we want to change the smoker to a thing called label. And label means output variable here. So basically, it's our target variable. And the RapidMiner is going to use all those attributes marked as label as output. And then use other variables marked as regular, right over here, marked as regular as the input variable. So that's the thing this setRow operator can do for you. Another way you can change it, for example, if you want to use the same data set, you want to pick just the same variable as output, and you don't want to do something like what I'm doing here and to put the full setRows operator for each model. So you think it's too complicated? Another thing you can do is that you can modify your data set or original data set directly. So you can see on the sidebar repository, I have my data insurance right over here. So I can right-click my insurance and click the second button in the menu called Edit. So when you click that, there will be another panel shown in the bottom and showing you the whole data set. It's like a preview of your data set. It includes all your variables and include one additional column called the row number. So it's just like an ID number and indicates the number of observations. That's it. So the row number will not be used for any analysis. And then all other variables are the same we have in our data set. And you can see that on the header, you have 3 kind of information. The first information is the name of the variable, and second information in the parentheses, it shows you the data type for this variable. It has the integers and the real number, which is also numerical data. And for categorical data, it's called the polynomial data. And we don't have a text data or something else. So you only see this 3 kind of types, integer, polynomial, and real. And then the third information we can see here is on the bottom, regular, regular, regular. It's regular for all the variables. So it means all the variables, they are kind of like equivalent to each other. So they are under the same row, and we just call it regular. And that's it. So we can use that the data set directly for clustering without problem. But if we would like to use it for classification, we need to set the row, right? So what we can do is we can edit the row for a particular variable in this data editor directly. We pick our smoker, and you go to the column header and right click, modify attribute. So the first one here. So after you click that, you're gonna pop up a window called Modify Attribute Smoker, and you can change these three types of information. You can change the name, the tab, and you can change the special row here and change it from regular to label. Apply it, and that's it. So in this case, you don't need to use a set row operator. Instead, you can change it manually in your original data set. And the only drawback here is that if you change it, it applies to your original data set. And if you would like to use a data set on some other models, you have to change it back. Or you have to add the set row operator to modify the row for a particular variable again. So what I prefer to do is, so I just add the set row operator in my process, and that's it. So I can still use my original data set for under analysis. Okay, for the data editor, if you are done, you can just close it. Simply close it, and we can come back to our process. So that is what I did for the second step, and choose the smoker as a label, which means a target variable, and that's it. And then I have the four models, and you can search the model in the operator's list just by its name, like KNN. You just search KNN, and that is one under the lazy algorithm, and it's just called KNN, and you can use this operator. Decision tree random forest, you just search the full name. SVM, you can search SVM, and you can get the full name called support vector machine. And you just simply drag the operator to the process. That's it. So that is the full green button. For the first three, that's okay. You just use that directly. And you can do some settings as we mentioned in our lecture. For the KNN algorithm, we can set how many Ks, basically how many neighbors we want to check. And the KNN is, we don't really have the actual model. And we don't really see an actual model because it's a lazy, we call it lazy non-parametric method. And we don't have an actual model. So it just get all your data and the weight. If you have a new data observation, it's gonna do the prediction for you. So we simply put it here. For the model, we don't really see any specific thing. And for the settings, we just need to set how many neighbors we want. And then major tabs, because we have both numerical data and the nominal or categorical data, we can keep as a default called the mixed measures. And the mixed measure, we can use the Euclidean distance to measure the similarity between two observations. And that's it for the KNN operator. For the decision tree operator, more settings. You can set the criterion used by the decision tree algorithm to split your data set. Gain ratio is 1. We can do information gain or Gini index, so accuracy of least square. Also, all like measures for the purity of classified group, and to see whether we separate our data set into a good set of groups or no. So it can be used as a criterion to split our data into a hierarchical structure or into a tree. And then we can also find the size of our tree and using the maximum dips. So basically, because it's a tree structure, we have different levels, and you don't want your tree to be very large, and you can limit the size of the tree. You can make it smaller by changing this maximum dips. You can change it to, for example, 5. So that means your tree will only include 5 levels. Or we can keep as the default, just 10, maximum 10 levels. And here, other settings about our tree splitting, minimum gain and minimum leaf size. So for each leaf in the bottom, how many observations you want to have in the leaf. So at least, so that means the leaf size. So at least 2, that's what it says here. So the settings, you can modify it a little bit to see the difference in the decision tree. Decision tree, and that will be it. After you finish the setting, it's gonna return you a model which looks like a tree. So we're gonna check that later. In the third model, we have here called the random forest, which is a combination of a bunch of decision trees. And similar setting to decision tree, you can set the criterions, you can set the maximum depths for each decision tree. One additional setting on the top is the number of trees, how many trees you want to have in this random forest. And that is the setting you can change. So I'm gonna keep the default setting 100. And then the last one, the SVM, this one looks a little bit different because different from the first 3 models, which can take all kinds of variables as the input. The SVM, you can consider it as a purely mathematical method or model that can only take numbers. So which means if you have nominal observation or nominal variables, which means labels on categorical variables, you cannot use it for your SVM model. You have 2 choices. You can either change your polynomial type variable into numbers. So different ways you can simply change the encoding for each category into a number, or you can change your categorical variable using one-hot encoding and to put it as a set of dummy variables. So different ways, but anyway, you need to change the polynomial variable into numbers. So that is one issue we have for the SVM. In my example, I simply add the select attribute operator to select the attribute filtered by the attribute type or value type. And I only want to include numeric variables into my SVM model. So that will not give you an error or warning. And then that will be it for this SVM model. I also have the notes here. And just a reminder that SVM can only handle numeric variables. Okay, so that's done for our classification model. Whatever you have done on the left-hand side on your dataset part, and you can finish it. And at the end, you will have a dataset. And all the classification models only take 1 input. It's called the training dataset. So you can see only 1 input node. You just need to link to the dataset you want to use with your classification model operator. And then for the output for each classification model, it will have at least 2 things. The first one is the model itself. It's going to show you how the model looks like. And the second one is called example set. So that means the data set you use for your model. So this example set will look exactly the same as your input data. So that is the 2 nodes that you will have for each classification model. And then for like decision tree, random forest, and SVM, it will show you the weight for each attribute. So basically, you can think it as the importance, how important it is. And in this case, we just simply want to see the model, so we don't really want to see the weight. That is why I didn't link it with our output. So I link all the 4 models, the output of the models with the result set. And after that, I think we're good. So we can just run our process. Clicking the run button or start the execution button on the top, and we wait. Then you're gonna see our model results. And for each model result, and it will show in a tab, and the tab is gonna have its own name, so it will not confuse you. And we can see how the model looks like in RapidMiner. For KNN model, again, it's a non-parametric model. It doesn't really have a model. It just tells you that we are doing a weighted 5 nearest neighbor model on a output variable, which has 2 classes, yes or no classes, and we're using 1,338 examples of observations with 6 dimensions, which means 6 variables. And that's it for this KNN model. In another video, I'm going to show you how to use a KNN model to make a prediction and how to evaluate the model. So that's a final output from the KNN model. Next, we're going to check our tree or decision tree model. Decision tree model, you can see something. You can see this tree structure. So then in this case, you can see the whole tree on the top will be our root, and each edge or the branch of the trees, and you can see the size and how the tree got constructed. So basically, if it is a numeric variable and it can for the model, it can help us to set the threshold and split the data set into 2 parts. If the variable or feature used is a categorical variable, like here, the sex, it's gonna use the categories. So for sex, we have male, female. So we can make use of these 2 categories and split our data into 2 subsets. So then on the top of the tree, let me make it smaller. Right over here, on the top of the tree, we have all of our observations. If you put your mouse here, it's gonna show you it's 1,338 observations. And then we're gonna split it. How we split it? It tells you on the node. We use the charges to split it. A threshold you can see it on the branches. And then, for example, we go here, the next level, and on the first subtree, we have 353 items. On the second subtree, right over here, it isn't coming out. I think we're gonna have 985 items here. And then again, the node shows you which feature the decision tree used to split our data and what will be the threshold. And charges will go down BMI and BMI charges, and we keep going to the end. In the bottom, let me make it larger. So in the bottom, you will see some we call the leaves. There's no breaking down anymore. And each leaf, you're gonna see a label, either yes or no label, and that is a label we have on our smoker variables. And you will see a bar and shows you 2 colors. The blue color, which means yes, and the red color, which means no. And then, although each leaf is gonna have a label, it doesn't mean that all the observation in the leaves will have the same label. The label on the leaves is determined by the majority items in this leaf. So probably you have, like right over here in this yes, we have 8 items in total, and we have 7 yes and 1 no. The majority is yes. So that is why the system assigned the yes label on this leaf. So that is what it is doing. And then at the end, you will see a bunch of leaves and all the decision rules in the tree. If you count how many levels we have, you see we have 10 levels, exactly the same as what we set in our decision tree. So that is a result for a decision tree. The extension for decision tree, random forest, right over here. So random forest, on the left-hand side, you're gonna see a list of trees. You're gonna have a bunch of trees. And because we set 100, so basically you're gonna see 100 trees. And you can click each of them to see how it looks like. And each tree will look differently because a random forest tree, every time it randomly select a data and create the tree. So that is why it look differently. And then that will be it for the whole random forest model. That's how it looks like. At the end, SVM model right over here, it tells you the weight for each variables it used because we only select numeric variable. So that is what we have here, so 4 variables. And you can see there's a support vector virtualizer. So basically, you see how SVM helps you to split your data into 2 groups. And you can see, looks like here is a pretty clear line or boundary between the blue and this green group. And that is how the SVM model looks like. So that is the result that you can see from these 4 different classification models. Again, here is our process, the design for the process, and the different operators you can use. In the next video, I'm gonna show you how to use this 4 different classification models and to make prediction and how to evaluate the performance for this prediction.